All right, hello Python developers and welcome. I'm going to step through module 10, all the content there, and we'll be looking at text and binary files in this module and stepping through most of chapter 8. There's some select portions that I'm going to skip just because they're a little bit outside the scope of this course, and wanted to really focus on the really powerful methods that we'll come across with manipulating files in operating systems. So here is our Jupyter Notebook demo file for this module, and let's just step through it. First, we are going to be using the OS, the operating system library for this, so we will import that. And we get a couple of really good utilities right out of the box with that. And let me draw those out on the whiteboard and list those. Here's some of the common methods that we'll get with the operating system library, the OS library that we've imported. The very first one here is to simply get the current working directory. CWD stands for current working directory. Let me jot that down. And this simply returns the exact directory that we're currently navigated to and working with. We can easily change directories with os.chdir. And we just simply put the new directory path here, a fully developed and fully realized directory path there inside the parentheses as the argument. And then just keep in mind, when you're working with Windows, you'll need to use the escape sequences. On a Mac, you'll have to use the reverse slashes. And just so keep that in mind when you are working on your platform, just what the syntax is required for each of those. Now, just like if we were in a terminal, in either a PowerShell or we've just got the command line, and we were to type dir for directory, well, we can do the same thing in Python here with os.listdir, and that'll give us an output of all of the contents in that current working directory. Now, we can also check to see if a file is there or not. We do that using the isFile method, and this will just return a true or false. If the file is there, true. If it's not there, false. And this is a quick way to validate that a file exists before we try and, for example, manipulate it, open it, any of those things. So we do have an extra path word here that we've got to use. So the full instruction is going to be os.path.isFile, the extra little path in there. And then, of course, the file name goes in there as an argument. And then don't forget, any file name will have to include either the single quotes or the double quotes, just to specify that as a string, since it takes a string argument. Then the other operating system method that we have access to is to delete a file. And that's just with os.remove. Keep in mind that this is permanent. And once you get rid of it, it is gone. Your directory, might put it in your recycling bin depending on what kind of a system you're on. But for the most part, you can count on that being gone. To validate that it's actually been removed, you could certainly do another isFile instruction and on the same file name. And if this gives you a false response, well, then that's your guarantee that it has been successfully removed from the directory system. Okay, we're back in the main window now. And I'm going to continue to scroll through our Jupyter Notebook here, just kind of demonstrating these instructions now that we have got a little familiarity with them. Here is they get the current working directory, and you see the results there. And yep, I'm currently navigated to my comp sci 240 directory. We can certainly change the directory with chdir. And again, a reminder to use the correct escape sequences for the backslashes, either the forward or the backs. Here is list directory, and this outputs everything in that directory. And as you can see, I've got a ton of stuff in there. And then here are a couple of instances of the is file. So here I'm just creating, seeing if a certain file is there. You can use remove then to remove it. And then if you run is file again on that, you will get a false just to validate that it has been removed properly. Now next, here is a very good, somewhat bulletproof code block that is going to open a file. It'll open a file of the user specification. So it's going to get a file name from the user and then try to open that. If it's not found, we are going to get an error, a file not found error. And we've got a try except block inside this, this loop here that will catch that error and give a statement out to the user and ask them to re-enter. Now, this sequence of statements here is first going to get a file name from the user. But then if the user decides, okay, I'm done, I don't want to do this loop anymore, it kind of does an elegant way of stopping the loop. And that is just if the user presses enter, which essentially means an empty string has been entered, then that signifies that they want to quit. Well, how do we test for an empty string in Python? And it's this simple, if not string name. So if this evaluates to true, it means then that the string in fact is empty, and then we will quit through a break. We'll get out of this loop through a break. Otherwise, it's saying, all right, let's go ahead and try this. We're going to try and open the file that has been referenced in the variable fname. And of course, we will always create a file read object called f or file or in file, whatever we're used to here. This is the exact same thing. So here, if we were successful, now we're going to try to open this file. If it's not there, we get the error message. And if that is successful, well, then we continue on executing the rest of this code block here. So remember that that's the try, except, else block to make sure that we successfully read it, find it and read it, and then we can successfully then read and process and manipulate it. So the rest of the code here is just we're going to take everything from the input file object and read it. .read is, as we know, and we'll talk about this a little bit further down, will read the entire file and store it into a string. So here, our entire file, new line characters and all, will get stored in the string variable story. Then, of course, we can just close it and print it. So once we do that, we see here the output. A short story, and here's the crazy good Pulitzer-winning short story that I was really up for weeks writing, and this is what I came up with. I hope you're impressed, because this was work. This was a lot of work. So here's my short story, and you see here that that it's properly output. Okay, the next thing that we're going to look at is the with statement. And what the with statement gives us is built-in functionality as far as the open file statement. If we use the with open statement, well, then we don't need a separate open because it's going to be included as part of the functionality. It's also going to allow us to provide the arguments of the file name and the proper mode that we're opening this file, either read or write or later even binary. And then it lets us define our open file object that we'll use as a reference for the open file. So here we are using the exact same code that we did before. This while true statement. Here we'll get a string from the user. Here we'll check to see if the string is empty or not. If the string is empty, then we will break out of the loop and stop. This time though, we're going to use this with statement, and it's going to be with open, the two arguments, as f, and that f is a programmer defined entity here. It's just a variable. So we could call that in file, f in, things of that nature. So here I'll just keep it as f. Later I'll call it something else. And then we get the rest of the statements there that will read the story and then output it. And then we do need to close the file once we're done with it. Let's always be good stewards of our file operations, and that which is opened, let's make sure that we close it. All right, this next little code block here is going to use a different mode, a different access mode. We're going to use the append mode, which will allow us to write data at the end of the file. That's what append does. It always goes to the end of the file and just starts writing there. So our goal with this little code block here is that we're going to just write the end at the end of my Pulitzer Prize winning brilliant short story, and just sort of give it a complete ending there. So let's step through this code and make sure that we understand it. First, remember that we're using the A tag for an argument to signify that we are appending this file. So here, my file object, I'm going to call in file this time, and we'll use the same with open instruction. There's my actual story.txt reference there, the file name, append mode, and then as in file. And then from here, we're just simply going to write, we can use the .write statement, and that will write one string to the file. And I'm going to write in a couple of end-line characters and then just the end. Now, once we're done writing, we have to close the file, and that's going to be inherent with the open statement. And then we have to reopen it in order to read it. There's a purpose behind that. And let me demonstrate what's going on there. Just to review, we did cover this a lot in CompSci 140 with file operations, but just to review the concept of a read head, let's go over to the whiteboard. Okay, the read head is simply just like a needle of a record player. It's where the processor is currently reading the file, and there's only one place at a time where a file can be read. Can't read it from two simultaneous locations. Now, when we open a file, the read head is automatically reset to the beginning of the file. But then as we've got content here, and as we process that content, the read file will always move over here until it's consumed that line and then go down to the next line. The read head then will process that line, until finally we get the read head sitting right there at the end of the file. And this is a special state that we can actually test for, and it will tell us that, okay, we're at the end of the file. Now, when we write something to the file, we're going to write it, and then we close it. And but the read head still stays there. Sometimes we'll have to go ahead and reset the read head. And in just a minute, we'll go through how to do that manually, so we don't have to keep closing the file just to move the read head up. Soon we'll be able to append to a file, and then without closing the file, we can just reset the read head to the top and then go back and read the file. So that's what's coming real soon. All right, so here with this as usual, we're going to read the entire file into a string called story and print it out, and then there's our output, just like we had before. Interestingly, just about every file you can imagine, you can go ahead and just store into a single string. a Python string can hold a ridiculous amount of data, up to about 63, 64 gigabytes of data in a single Python string. And that's a lot. So you're not going to run out of room if you're thinking, oh, I better not store the whole file into a single string because there might not be enough room. There's enough room. Also, when we do this, it will store end line characters. So the formatting of our story stays intact, even though we are reading that file into a single string. Okay, now here's a little bit of code too that is going to actually try and strip out the end that we had just written up here. You see that in file write the end was in this code block, and then we reset the file up there and read it. Well, let's say I just want to strip that out. I'm going to use a little different technique to do so. And what I'm going to do is then strip off like the last 3 lines of this story, and that'll kind of capture the end. And by the time this operation's done, we'll have stripped that out. So let's take a look at this. If we remember right from comp sci 140, the dot read lines method is going to read the entire file, except it's going to store every line as a string in a list. So read lines is actually going to return a Python list. Always remember that, because now story by definition is a list, whereas before it was a Python string. So keep your data types fully managed here. Here then, once we get the story, we can use the shortcut for loop that's just going to go all the way through that list. And every time through, it's going to print out 1 line of the story. And since the story has new line characters embedded into it, well, that's why I'm suppressing the end line here in this print statement, because our story already has that. Now then, what I'm going to do here is just a little bit of list comprehension. I am going to say, okay, give me everything but the last 3 lines and rewrite story with that. So inside this Python list is, first of all, a colon. And since there's no value ahead of it, the assumption is go from the beginning to whatever is after this colon. Well, what's after the colon here is, okay, length of story, that's going to give us the number of items, and we'll just subtract 3. So if this is the whole story, I'm going to take the whole story except those last 3 items. They're going to stay over here. And now this part of the story, which is this part of the list, I'm going to copy to story. So that's an easy way to just get rid of some extra lines there at the end. You can see here then when we print that out, that the new listing here omits the end part of it. Now, I had just mentioned that it's possible in Python to actually reset the read head manually. And we can do that with .seek. .seek will send it up there, and it takes a couple of arguments. If we use 0, 0, that's going to reset the read head to the beginning of the file. So here is the same appending code block that we had further on up. That's going to write the end at the end of our story. But with this, we're first going to write the end, and normally we'd have to close that because we're doing a rewrite. We're doing a write operation. We'd have to close the file in order to do a read operation. But what we're going to do here is use a trick that rather than opening the file in just simply append mode, we're going to read it into append/read mode. And that's going to be with the tag A+ that's sent then as an argument to the open method. A+ means we're going to both append and read. W+ will be both write and read. So you kind of get the idea there. So we write to the end of the file because we're appending. Then our next statement resets the read head all the way to the top of the file. And then this next statement will read that into the file or into this string, and we print out that string. So there's the output there. And the end should be stripped out there. I mean, the end should only appear once. It just happens because I did some of this Jupyter Notebook processing out of order that it has an extra one in there. Now, as a matter of refresh, the next three little code blocks are just a reminder about what .read does. .read will read the entire contents of a file into a string. And note here that you can create a separate string variable if you're going to need to manipulate it later, or you could do slightly more compacted code with that. And let me demonstrate that next. All right, so how I'll demonstrate that is I'm just going to create another cell here with the plus button. I'm going to copy all of this into the new cell. Oops, not that. And I'll show a slightly more compact way to do this. If you don't need to store the entire story into a string, matter of fact, maybe you just want to print it out real quick, you can do the whole in-file operation, read operation as part of a print statement. And this makes it very compact. And there you can see the short story is output. And again, this bypasses storing the contents of the file into a string, and it just sends that string to the print statement and it prints it out. So kind of a cool little trick if you want to compact your code. And again, this is only if you don't need to store that for some later manipulation. All right, reviewing kind of the file read operation instructions that we learned in Comp Sci 140. Read line is just going to read a single line, and it returns a string. So remember that. However, a lot of students get read line and read lines, plural, mixed up. An easy way to remember, of course, is read lines is going to read all of them. Read line is going to read a single line. But the big distinction is that read lines is going to return a Python list. Read line just returns a Python string. So remember that behavior in your coding. So here's now what read lines is going to do for us. And you can see that I've got it in a very compact mode here for line in file.readlines. That's an easy way to just get the file read. You'll note here that this code is very compact and efficient, and it's going to do the trick. However, it does not store the story or the input file in a variable for later manipulation. So just be very aware of that. Okay, now we looked at the read methods. Let's look at the write methods next. Write will write a single line to a file. And note here that I'm going to start to slowly build our complexity in these code blocks. So the first thing to note here is that the file mode is W+. And I mentioned before with that code block above, of course, W is for write. The plus gives us even more capability of reading, and this then allows us to do both a read and a write operation on the same file at the same time. We'll just have to manipulate where we put that read head. So we will write this string to the file, and then we will reset the seek head, and then read the file. And then there we get the output there. Pretty straightforward for that. Write lines is going to take an original list of strings and write all of that to a file. So remember, the opening argument to this is you've got to have a list of strings. So here is a list of strings. Note that we do have to include the new line character in this because our story is not going to strip those out. It's going to rely on those to preserve the formatting. So here's my string list. Now is the time for you to learn some awesome Python. And then we'll pretty much use the exact same code block, except this time rather than write, we will use write lines. And we give it the argument of the list. And you can see the output there is all intact. Okay, the last part of our demo here is binary files. So far to date, and probably all through CompSci 140 as well, we've just been dealing with regular everyday text files that we can easily open up in File Explorer or our Finder, open them up in Notepad, and there's our file. But so much of computer science is actually in binary files. Since the efficiency and the coding of those is so much more efficient. So the next part of our demo here is going to dabble in binary files and how can we navigate in and out of binary files? How can we go from a text file to binary and binary back to text, etc. So we'll look at that next. First of all, when we use binary, all we're going to do is change the arguments tag. So rather than opening a file in R mode for reading, or W mode, or A+ mode for append write, we're just going to use a new tag. And the tag ends with a B, and that's B as in boy, and it stands for binary. And then we'll usually use that in conjunction with either write or read. So RB or WB for read binary or write binary. So given that, here's a little snippet of code from the book that writes some data. It writes actually some hexadecimal numbers to a file, but it does it in binary mode. Now, here's an interesting thing about the file here. Since we are writing to a file, Python and C++ does this also, Java also. If this file does not exist, well, then the processor will create it for us. So it's not necessary when we're writing to a file, it's not necessary to first check for that file's existence, except if you're going to try and append to the file, if by nature, if we're appending, we're assuming that a file exists and we just want to write to the bottom of it. So we would have to check for the file's existence if we're going to append or even write or even read, I should say. But for writing, no, we don't have to. Now here we're going to use the same with open statement, and we're going to output it to output.dat. We'll use the mode WB for write binary. And my file object name this time is going to be out file. Now, another little bit of kind of trivia and just standard practice is that, when we're writing to a text file, we've always just used the .txt extension, simple. As a matter of convention, if we're going to write in binary mode to a binary file, we'll usually end that with .dat for data. So keep that extension in mind, and it's right away a clear indicator if we are in text mode or binary mode. So this file or this instruction here, the write will write, again, the beginning B means we're going to write a byte stream here. We're going to actually write a byte, and then it's going to put these numbers into the file, and these are just by hexadecimal numbers. The escape sequence \x indicates a hexadecimal number. So we should get 1, 2, 3. 10 in hexadecimal is actually going to output as 16 because it's base 16. 20 should output as 32, double the 10, and so we'll see what we get there. So this then will successfully write to the file. Now let's take a look. Now that we've got a binary file, how do we read from it? So first we will use the same with open statement and just change the tag to RB read binary. We will use infile.read to read the contents. All of those then will get stored in this string here, or I should say this list. Since it's binary, we're going to deal with objects, so it's not all going to come in as a list. And then here we can just simply step through that list and output the data that we encounter there. So you see our output there was the output that we were expected based on this writing operation that we did further on up. Now, if it's not necessary to store for later manipulation or safekeeping the contents of the read file, well, we can rearrange our code and compact it a little bit for efficiency with this code here for val in infile.read. So this will assume that we've got, since this is binary, it's going to return a list, and this will just step through the list. So just slightly compacted code. A reminder again, don't use this if it's going to be important to store that read data in some object that we can later either access, maybe we have to manipulate it or something. All right, well, the last part of our demo is going to be on pickling binary data. What pickle does is it gives us access to a lot of really sleek methods. And these methods will let us kind of go in and out of binary mode and text file mode really super easily. It's almost like pickling data in a jar. You know, we want to put it in a binary file. So, okay, let's just pickle it all, put it in a jar, and there it is. Later, we can open up this pickle jar and open it up and look at the contents and decide what we want to do with those contents. So we'll first look at the process of writing to a binary file, and then we'll look at reading. Now, we'll have to use the pickle package. It's a specific library. So we import pickle. And then here I'm just creating 3 different types of objects. We've got a Python list, we've got a string, and we've got a float. So what we're going to do here then is take these 3 objects and pickle them. That means we're going to write them to a binary file. The pickle methods are just so comprehensive that we can just, with a simple method call, take care of this without a whole lot of extra coding or worry. So let's take a look at how we can write these to a file. And we do that through the pickle.dump method. And it's like we're dumping these in a file. Yeah, they probably could have made it, pickle.write, but we're not really writing the data here. We're really more storing it in a binary file in a format that can be retrieved later. So that's why it's called dump. All right, so let's pick apart, now that we've got these 3 objects, let's pick apart this with statement. It's still with open. There's our data.dat. That's going to be a user-defined file name. WB for the write binary mode. And then the file object name is file in this case. And then all a pickle.dump method needs are those 2 arguments: the object that we're going to dump and the destination of the dumping. Once we execute this code, well, great. Now we've got then a binary file with those 3 objects in it. Now, what's interesting is that if you go then in your File Explorer or your Finder and look up this data.dat file, it's really going to be gobbledygook because it's in binary mode. It's not in text mode. You're not going to be able to read it like a human could and understand its contents. It's in binary mode, so you'll see a lot of strange characters in there, and we don't even care about what those characters are. The processor cares, and the processor is going to take care of those and take really good care of those objects in there. So that's the way to write binary data to a binary file. Let's reverse the process now, and let's read those objects. So we've got the data.dat. Let's read those objects now. So our with open statement is going to be exactly the same, except Our file access mode is RB for read binary. And we'll use the pickle.load file. Now, all pickle.load is going to do is go and find the first object in the file and return it. So we'll then assign that to the variable A. And we'll do that a total of 3 times because we know there were 3 objects in there. Then once we got the objects assigned to variables that are local that we can manipulate, we can just print them out. And this is kind of a cool thing too, that any Python object can report its own data type with the type instruction. So there, I'm first going to print out the type of object A, and then I'm going to print out object A. And you can see here that we get, okay, this is a list, the next one's a string, the next one's a float. And isn't that kind of cool? It's neat that an object will report its own data type. C++ doesn't do this. It takes a lot more coding to find out if something in C++ is actually an integer. But Python does that a lot more smoothly for us. Now, this code all worked just fine because we knew that there were 3 objects in that binary file. But what if we don't know how many objects are in there? Well, let's just put it through a loop, and we'll keep going through that loop until we run into end of file. So here's some code that's going to do exactly that for us. And this is the last little segment that we'll take a look at. The first thing that we'll do is create an object list that's empty. And we will just, as we read from the binary file and pull an object, we will then just append it to that list. So at the end of the day, we'll have this list of objects. Okay, our with open statement is exactly the same as before. We have the same kind of a loop going. We'll have a while true loop here. And we're going to try to load that file. Load that object from the file. We'll assign it then to the variable item. Now, we'll try that. If it doesn't work, well, that means that we have hit the end of file. So if that's the case, well, let's just output some metadata. How many objects did we actually get? And we can get that number by looking at the length of the object list. And that tells us how many successful load operations we got. And then when that's done, we'll just break out of the loop. Otherwise, we will print out the item. And then this is important. We will then append that item to our running list of objects. And this means that later in our code, then we can access that, that object list, reprocess the elements in there if we need to, manipulate them however we need. So I hope this helped. I hope it was a good demo of some of our file operations and binary operations. They should set you up neatly for this week's programming assignment. So good luck, everybody, and we'll catch you soon.